ചന്ദ്രയാൻ 3 നിർദ്ദിഷ്ട ദൗത്യ കാലാവധി പൂർത്തിയാക്കിയ ശേഷം ഇപ്പോൾ ചന്ദ്രനിൽ ഉറക്കത്തിലാണ്. നമ്മുടെ കൂടെ ഇപ്പോൾ ചേരുന്നത് ഈ ദൗത്യത്തിലെ വളരെ പ്രധാനപ്പെട്ട രണ്ടുപേരാണ്. പ്രൊജക്ട് ഡയറക്ടർ ശ്രീ വീരമുത്തുവിലും അസോസിയേറ്റ് പ്രൊജക്ട് ഡയറക്ടർ ശ്രീ കൽപ്പനയും. നമുക്ക് അവരോട് തന്നെ ചോദിക്കാം, എത്രത്തോളം ദുഷ്കരമായിരുന്നു ഈ ദൗത്യം, ചന്ദ്രയാൻ 3 വിജയത്തിന് ശേഷം ഇനി എന്തൊക്കെ നമ്മളെ കാത്തിരിക്കുന്നുണ്ട് എന്നൊക്കെ. ആദ്യം ശ്രീ വീരമുത്തുവിലേക്ക്. സർ, ഇറ്റ് വാസ് എ വെരി ടഫ് ജോബ് ടു ഗെറ്റ് ഡൺ, ആൻഡ് ആഫ്റ്റർ ചന്ദ്രയാൻ 2 you took over as mission director of Chandrayaan 3, and the journey was 4-year journey. So when you look back now, after the whole thing has been completed and the mission duration is over, how do you look back to that journey, and what do you take away from this 4-year long, 40-day long journey?
It's really amazing, and I am very happy, and our team is really happy. And it's quite challenging because after the setback from Chandrayaan 2, we have to thoroughly understand what went wrong and how to do a corrective action. That was our first task, and then further to that, reconfiguring the spacecraft and building the robustness and handling failures. Whatever the failure we can foresee, how to build that type of capability in the hardware as well as software, and conducting the test in Earth, simulating the moon's environment. Whatever the test we conducted during Chandrayaan 2, some of the improvements is really called for. So we have conceptualized what are the tests we have to do, and we conducted a series of tests. One such test is integrated cold test, where we flew all the sensors and the navigation system in the helicopter over Chitradurga area, where we created artificial craters and boulders, and we have done a series of tests in evaluating the sensors, evaluating of all the sensors of absolute sensor, hazard detection and avoidance sensors, inertial sensors. And then the second test was integrated hot test that we have conducted at Sriharikota, where we created a new test setup and test site, wherein we conducted a series of tests starting from dry run, static test, and the closed loop test, where we put sensors, navigation, guidance and control, and the propulsion system in closed loop. And the third test was the lander leg performance assessment test, where we conducted a series of tests again in simulating different touchdown conditions like horizontal velocity, vertical velocity, combination of slopey surface and then the flat surface, hard surface, soft surface. Like that we conceptualized and conducted. And the last part is the multiple mission parts we built in the actual power descent phase. So whatever the failures are anticipated, it should take a real-time decision, and it should still land safely and softly onto the lunar surface. That was our goal. It was quite challenging, and the entire team has contributed. I am representing the entire team, and the entire credit should go to the entire Chandrayaan 3 team.
Talking about the team, we know that even though you are the faces of this team, there's a big team in the background who we may or may not see in the future. So how big was this team, and how was this team building reality? There are a lot of people talking a lot of languages, people coming across centers. How did you manage to keep these people together and move forward towards a particular goal, that is soft landing?
Yes. So when you talk about the technical challenges, equally the challenges in handling such a big team, as you rightly said, the team is not stationed at one city or one center. They are spread across different cities actually, starting from Bangalore to Ahmedabad to Trivandrum to Hyderabad, and like Sriharikota, where the launch happened. Like this, the team is spread across various centers and of various languages, as you rightly said. So this team management is a very important task when we are handling such a mammoth project. The scale of the project is very high. The number of modules we have built all have to integratedly work together. When I said team is spread across all centers, each one have their own responsibilities and hardware deliverables and software deliverables. Each one will be independently developing these modules, but all have to come together, and all those systems have to get delivered and integrated, and it has to work in perfect sync. So for this, good amount of planning is required, and from the beginning we should be very clear on what we are doing. Very good interface management is required, very good documentation is required, good amount of interface meetings. That is the initial phase of the project actually, where we build everything on paper first, then only the actual hardware start building. But that first phase is very important. That's how all the teams who are going to independently develop the systems will clearly know what they are going to do. For that, project as a center pivotal point will be playing a major role, and we'll be ensuring all the teams are in perfect sync. So team management is very important.
Talking about bringing the team together, you had help from veterans and people from Chandrayaan 1, Chandrayaan 2 teams coming in and contributing to the mission. How was that interaction with the veterans and fine-tuning things towards the end? Figuring out what exactly went wrong with Chandrayaan 2 and getting those lessons implemented in Chandrayaan 3. How big was that challenge?
Yeah, as I told, after the setback in Chandrayaan 2, there was a failure analysis committee was constituted by Chairman ISRO. That committee has thoroughly reviewed the onboard telemetry parameters, and we reconstructed the failure, and we pinpointed where is the problem. In fact, that itself took some 1 or 2 months, and further to that, we have also tested various things, and we had a handle on that problem, how to correct it. So those were all addressed in the initial stage of the project itself. Then only the new project was formed. And Chandrayaan 2 experience is greatly used. If you see the Chandrayaan 3, the most of the heritage is utilized from Chandrayaan 2. In addition to that, wherever the robustness we can improve, that was only addressed in terms of hardware and software. Every system has been augmented in Chandrayaan 3 lander. The main focus was for a lander, not for an orbiter, because orbiter is even now working. Even though the mission life of Chandrayaan 2 orbiter was 1 year, you may be aware that it is still functioning. It's more than 4 years over now, and we are expecting another 3 years it will work. In fact, that orbiter high resolution camera is being used for, we have used for thoroughly characterizing the landing site. So the Chandrayaan 2 experience is fully utilized, and the team is almost the same.
There were a lot of technical challenges that you had to face when you are simulating moon environments on Earth. Gravity is different. There is no wind there. You can't use normal systems that you use here on the moon. So how did you tackle those challenges, and what methods did you have to implement to tackle lunar gravity as it is?
So, for example, IHT, the integrated hot test, we could not contain the mass, 1/6 of mass of the entire lander. It is difficult. Even if you put the systems of propulsion system and the sensors, navigation, guidance and control, to carry that you need a structure. To communicate, you need an RF systems. So minimal systems are required. That itself is exceeding the 1/6 of mass. So what we have done is we used a novel method to offset that mass, even though the thrust is not adequate, because again the engines are sea level engines. So unfortunately the mass we are not able to reduce, and the thrust is also we are not getting 800 Newton. Because of the sea level in nature, we have got maximum of 540 Newton thrust. So to address that issue, we have put a counterbalance mass, so that you are giving an upward force. So by which we have conducted the test. That itself was a challenge. In fact, the conducting this test itself was a challenge. Compared to Chandrayaan 2, we have mounted almost all the sensors. Earlier we had only inertial sensor in Chandrayaan 2 time. So this time we have mounted all the absolute sensors, like altimeters, both RF based altimeter, laser based altimeter. Then we had hazard detection and avoidance sensor, and the processing electronics for that. And we had velocity sensors. One is camera based sensor, other one is laser Doppler based velocity meter. All those sensors also was part of it this time. Under the engine firing condition, the sensor assessment also was carried out. That was something unique. Chandrayaan 2, we did not have that type of test. So that also has been overcome by doing this test. That is one test. By having a counterbalance mechanism, we overcome that mass. The second one is the lander leg drop test. Lander leg drop test, we have gone ahead with the truss kind of a structure, where we contain the mass to 1/6, and the CG, longitudinal CG also simulated, because this is very important to conduct the stability of the test. We have two tests. One is to demonstrate the stability of the platform. Other one is to demonstrate strength of the platform. Strength of the platform, we can lower the height, because we have to simulate the impact energy. The impact energy simulating, by varying the height, you can achieve it. But if you have more mass, the height will come down, but you can still simulate the same impact energy. Whereas when it comes to stability, that too, the stability on a slopey surface like 12-degree slope, you require height which is equivalent to moon height. For that, you have to necessarily contain the mass to 1/6. For that, the truss type of structure has been used.
Okay, so that was some interesting info. So when we talk about landing, there is always this public perception. The public is always waiting for images, and getting those images back here is not easy as we have 5G speeds here. We don't have it on the moon. How did that work out? How is that system working for getting images from the moon and back? How difficult is that system, and what's the speed at which the images are received here?
Actually, that is one important improvement we have done compared to Chandrayaan 2, apart from all other technical improvements. See, this time there is we have two streams of data what we receive from the lander. One is in S band, another one is X band. So there is in this through this X band high data rate, with this time we have ensured such that we are receiving the lander images. You would have seen during the power descent phase, we were almost at a continuously at a frequency of say 4 seconds we were receiving the image, lander image. So this itself was a very good indication of how the lander craft is functioning, and in real time we were seeing the lunar surface images. So this time we made that particular improvement and ensured that the steering mechanism for that antenna is such that we are able to get the lander images throughout the power descent phase. As the lander is coming down, this antenna also was steered such that you're able to get a contact to the ground station and send the image down to earth. So that way we could able to get. And also other apart from this, even the data rates wise, data rate, when I say the telemetry data, the spacecraft health data, also the data rate, that is the sampling rate, more number of samples we are able to get to earth now. So that also we have made an increase. This way even the data what we are getting is improved compared to Chandrayaan 2.
So that's about the photographs coming in. The scientific data is very important, and that's something that the whole community is looking forward to. So we have a very small time frame to operate. It's 14 days, but we don't actually get 14 days, do we? How many days do we actually get for operations on the moon?
See, we actually got 10 days. The first 2 days and the last 2 days we should not account, because the sun is rising at 0 degree elevation, and it will come maximum 22 degree, and again it will settle to 0 degree. The sun will have an azimuth rotation of 0 to 180 degree, that it starts from east and it goes towards north and then finally settles at west. So this azimuth rotation is happening in this 14 days. Along with that, elevation angle is also happening from 0 degree to 22 degree. So the first 2 days, in fact, we landed on the second day. So third day onwards, we started operating the payloads. Similar way, the last 2 days also, the sun elevation angle will go to nearly 0 degree. So if you see, when we land on a south pole, where the sun elevation angle is very small, very low, it's lower. So even a small height will cast a long shadow. Like assume the lander height itself, it is about 3 meters. It will cast a very long shadow when the angles goes below 6 degree. So because of that reason, we generally don't operate. So we effectively got 10 days, but these 10 days we have operated 24/7. In fact, if you would have noticed, rover has been moved for about 101.4 meters in this 10 days. In this process, we had to overcome the obstacles like craters and boulders, and we also avoid the shadows coming from the lander. It has to generate power, and always the solar panel of rover has to track sun. So we had multiple challenges. Like rover is not directly communicating with Earth, it is always communicating via lander. So whatever the path planning which we have planned by taking the image from the navigation camera, and it has to be downloaded to lander, and lander will again download to Earth, and then we have to do DEM, digital elevation model, and then further control points and then mechanisms will generate the coordinates. So then the next process of moving from point A to point B happens. This entire process takes about 5 hours, and in this if you encounter some craters, we have difficulties, we have to take a different directions. In fact, this time we have moved backwards. The rover has been moved backward to avoid the shadow coming in that region. In fact, when the sun starts coming at east direction, the shadow comes onto the west. Then it moves to north, it comes to south. Similar way, when it comes to west, it casts shadow on the east. So almost the shadow is going to come on the east and south direction. So we avoided that direction. So these are the multiple challenges we had, but we operated all the scientific instruments, both in lander as well as in rover, for continuously 10 days.
So the rover did its job, all scientific instruments were used, but one surprise that came before the lander was put to sleep, we received the news of a hop test that happened on the moon. So was that planned before the launch itself, or was that something that was improvised during mission duration?
No, in fact, the hop-on was not part of our plan. This was actually suggested by our director URSC and chairman ISRO. This should act like a precursor for the sample return mission, and this is something a new thing which they have pushed our team to our limits to conduct this test. In fact, we worked for almost 24 hours continuously to conduct this test, and this test has really it's like a huge success. We did not have much confidence, like it was not our, as I told, it was not our plan. We have to fire the engine in an open loop way, and it has to take some it has to hop, it has to have some upward direction, and it has to land onto small lateral motion. So this is something very phenomenal, because all the legs are not equally placed onto the ground. Some legs are inside the regolith, and the terrain resistance is involved at the time of liftoff. So many challenges we had, but all those things, the credit should go to Director URSC and Chairman ISRO, because they told we are behind, you conduct this test, and successfully we conducted also. It's a huge success, I would say.
That was a very pleasant surprise from Team Chandrayaan 3. Taking off from the moon is different from doing it on Earth, and also your mass calculations, everything has changed from the time of landing. So how did you actually manage to find the courage to do that? So there is a chance that after the hope test, the lander may topple or something like that. So how did you manage the mass changes, and how did you get that thing into action?
No, as he was telling, this was not a planned event, because when we landed, for the scientific instruments to function, we have done a lot of deployments. First of all, for the rover to roll out, the ramp was deployed. So ramp was in a deployed condition, as you would have seen. The payloads, Ramba payload was deployed. Our chastity probe was deployed. ILSA was on to the ground. So these are all for a post-landing operations. It was in such a situation. Now we are thinking something totally different. It was an out-of-the-box idea. Now to implement this, again, we have to go back to such a situation. We have to bring back stow the ramp, and again the chastity probe has to be retracted. ILSA has to be again brought. These are things which we never tested on ground, but again we are going to do it on lunar surface for the first time. So all this, we had enough discussions on that. We had a proper technical discussions and planned how to implement that, and also to a certain extent we have done some simulations also to do the hop test. What are the conditions to be accounted? So all this systematically we did, and that whole night, as he said, 24 hours our team was fully on job, and all concerned teams were worked towards it, and with all the encouragement from our management, we did it, and it was a huge success. And with this, there were a lot of good outcomes, because of this we have moved the downrange wise, we have moved to a slightly different location. So different science is possible. ILSA payload is again on a different surface. Chastity is going to do a thermal measurement on a different surface. This was another big outcome. So again, we could do some more experiments. So these are all the big outcomes. Again, it's some to a certain extent a precursor for a sample return mission. We have fired the engines again. All these are a very good outcome, and it's a phenomenal success for this.
Anyway, we are hoping for more surprises from the Chandrayaan team anyway. But one thing to note is that it's night time in the moon now, and sunrise is coming by September 22nd or something. So how hopeful is Chandrayaan 3 team of the lander wake up again? We know that it's not planned, and we don't have the sufficient nuclear technology available with us, but still we can hope. So how hopeful is the Chandrayaan 3 team of lander waking up again?
See, you have already told the mission life is only one lunar day, but in the power system of lander and rover, we have built a sleep and wake up logic. So now we have slept naturally. Now all the systems are in off condition. Once the temperature rises and a certain amount of power generation happens, the wake up will automatically happen from the power system, and the power system will come on. Both in lander and rover, that has been thoroughly tested. But power system alone coming on is not going to be useful. So the related systems like RF system, baseband system, those systems also have to come on. Once that comes on, then we can establish communication with ground. For that, rover, the entire rover of the QM qualification model has been subjected to a very low temperature of around minus 145 degrees centigrade, and we have thoroughly tested. And rover survivability is having a good chance, whereas lander is not being tested. So rover alone coming on is not going to help, because rover cannot communicate directly with Earth. It has to communicate via lander. So the hopes are there, but it is a hope. we cannot guarantee, and we are also hoping like you.
So let's all hope for that. So when that hope continues, and while we wait for Vikram to call back to Earth on September 22nd, one final question before we wrap this up. We have landed on the moon. Now we have to do something else next time when we go there. It can be sample return, or it can be some other sorts of experiments, or a different type of exertion vehicle. So what's the Chandrayaan 3 team planning forward, and what's the next step in the in space exploration?
We have a roadmap. Anyway, futuristic thing I cannot reveal. It will be a confidential, but certainly we are working on it for the future missions. So you can reserve this question to the higher management, ISRO higher management. You can ask the question to chairman and directors.